Part 2 here. So, if the garden watered now, I'm raring to go. So what's this? So write the following using sigma notation. Sigma notation is just in this form. Again, that big letter there, sigma just means, see there the red pen didn't show up too well. Sigma just means sum of, and therefore we must get Tn. Tn meaning the linear or arithmetic sequence. Now we know the first term obviously is starting at 1. We want to just find how far up it goes. And this one as well, you could just keep counting them up 4, 8, 12, 16, 20, 24, 28, all the way up to wherever you get to 1, 2, 4, and then fill it in that number. That's it. But we'll show you another method. So this is my linear arithmetic series. I want to find out what term number is 124. Yeah, I want to find out what term number is it, the 20th term, the 40th term, the 35th term is 124. How do we say that? What term number? So what Tn is equal to 124. So we must get Tn. Tn, if you look back at the start of the last one, you've got a little formula, Tn a plus n minus 1d, a being the first term here, which is 4, and your common difference also is 4 because they're going up in 4s each time. So fill that in, get your general or your nth term. 4 plus n minus 1 times 4, Tn is equal to 4 plus 4n minus 4, Tn, they cancel, 4n. So that's our general term. We want to say what term number is 124. That's how we phrased it. We know Tn now is 4n, so where is 4n equal to 124? And that just simply becomes an equation. N is equal to 31. So the 31st term is 124, and therefore to write that in sigma notation, sum, my Tnth formula, oh yeah, we did need to work this out, 4n, n is equal to 1. I'm just filling this in here, and we're going as far as 31, and that's it. That's that question done. So that was question 1 on page 15. So again, look over it, try it again yourselves, and practice it a few times. Laid out another question here to do. Oh yeah, so this is the example on page 14. Difficult example, as I say. So here they're saying to you, sorry, see after that there example 1, 2, 4, that is the same as question 7. So that there sort of thing is the exact same as question 7. So you try question 7 now. Actually, I have 7 part 2 here, I'll do it. And then you try 7 part 1 and 3. Yeah, so then that's 6 and 7 done. So this one here, starting at minus 10, there's a wee misprint in that one as well. They skipped a 1 or 2 of these. But anyway, this question is asking you get the general Tnth term and then go as far as how many. So it's a linear sequence because they've got the same common difference. They're going up in minus 10 to minus 9.5. It's going up in 0.5s. So your first term here is minus 10. Your common difference is plus a half, or 0.5 might be easier to work with. So we want to get the general term first of all and get our Tn. So Tn is equal to a plus n minus 1d, because that's what always goes after our sigma notation, after that sigma sign. So Tn is equal to a, our common difference 0.5. I just prefer the wee decimal to work with. You could use your fractions as well. Plus 0.5 n minus 0.5, tidy her up, minus 10.5 plus 0.5 n. We want to know how many terms there are until we reach 4. It ends. If they just continued on with decimals, that's it. But we want to see what term number is 4. So what term number is 4? And whatever term number is 4 goes in place of this question mark here. So how do we say that? English into maths. What term number is 4? And now we can substitute in our Tn. Minus 10.5 plus 0.5n is equal to 4. And tidy that up. 4 plus 10.5, 14.5. And then 14.5 divided by a half, 29. So therefore that written as segment notation. My sigma, my Tn, which is this. Doesn't matter what order you write it in. If possible, I always like the positive at the start. We're starting at our first term there, and we're going all the way up as far as our 29th term. And then that's that one done. So you try now question 7, part 1, part 3. Part 3 is 10, and your common difference is 0.1. You know, so stop the video and try that. And then the last one here is the example on page 14. So in this one here, let's have a wee look. What does it say? Alright, for what value of n? We have to find n. Is this equal to 90? So that there just means the sum of them. Remember, so what value does the sum of these terms from 1 all the way up to n equal to 90? So the first thing I would do here is work out my first few terms. So when r is 1, 3 times 1 minus 5, and this will allow me to get a and d. 3 minus 5 is minus 2. Then my second one, 3 times 2 minus 5, which is 1. And then 3 times 3 minus 5, which is 4. So I know that's linear because it's going up there and 3. So my first term there is minus 2, common difference is 3. And now I'm going to sub that into Sn, because that's saying where is the sum equal to 90? You know, that's all it's saying. Where is the sum equal to 90? So we fill this into our formula now. Sn is equal to n over 2. The sum of the nth terms. So Sn, n over 2, 2 times a. Getting tired now. And then once I've got this, again the brackets just mean multiply. To keep your cell right, maybe put that over 1 and then top by top, bottom by bottom. So 3n times n is 3n squared minus 7n over 2. Now since 2 doesn't go into them evenly, you could write 1.5n squared minus 3.5n. That's perfect as well. Now that's not this question done, because we said up here, where's the sum equal to 90? The sum of the nth terms. Now you've just got to say, replace your my sum equal to 90. Where is my sum equal to 90? Here, my Sn is equal to that. 3n squared minus 7n over 2 equal to 90. Now that's tough. There's no questions like that in your book. Must mean something from the exam papers. And once you get that far, you're flying. You know, you got an equation, cross multiply. 3n squared minus 7n is equal to the 90 times the 2 is 180. And then that's probably, I think that's solved in the thing. You'll do your minus b formula, or open up your brackets, and you get n is equal to 9. You get a negative number as well, you ignore that. So that's all that your answer is. If you wanted to write in segment notation, 9, r is equal to 1, 3r minus 5. So if I added up the first 9 terms, I'd get 90 in that. And the only other questions you had was 12 and 13. since I've went this far. I may t up 12 and t up 13 anyway. So 12, different to that. Show that the sum of the natural numbers from 1 to n is that formula. So sum from 1 to n. So that just means sum of your first natural numbers, 1 plus 2 plus 3 plus 4, all the way up to n, whatever n is. And once, how do we say sum? We use that Sn formula. Sn is n over 2, 2a plus n minus 1d. And then you fill it in. So a is 1, d is 1. A is my first term's 1, common difference is 1. Tidy her up. 2 times a is 2 plus n minus 1, common difference. Multiply that in. What do you have? 2 minus 1 is n plus 1. What did they say? Show that it is that. That's the answer here. And then use the formula to find the sum of them first 99 terms. And then your part 2, sub in 99 into that. Sub in 99 in for n. And whatever answer you get. I might finish that. 99 over 2 times 100, 4950. And then 13, I'll tee it up. Sure he's will get that finished then. And just a test of you watching this. Look at them for a purchase yesterday. Nice. So 13, the 21st term of an arithmetic sequence is 5 and a half. The 21st term, so how do you say that in maths? T21. The 21st term is 5 and a half. And the sum of the first 21 terms, the sum is your S. 21 terms is 94 and a half. Find the first term and the common difference. So we don't really have much to go with here. Maybe play about with this one. Once we see t, I'm thinking tn is equal to a plus n minus 1d. It's actually starting to make a wee bit more sense now. What has that 21 gone in for? It's gone in for the n. So t at 21 is equal to a plus, I've replaced my n with 21. T at 21 is equal to a plus 21 minus 1 is 20d. And then what did that equal to? 5 and a half. Now already that's starting to look like something. Then, look in this next bit, s at 21. I don't use this formula because this means the sum of the nth terms. Sn is equal to n over 2, 2a plus n minus 1d. We'll sub in 21. S at 21, 21 over 2, 2a plus 21 in for n. Yeah, 21 went in for n. S 21, 21 over 2, 10.5, 2a plus 20d. Tidy that up. No, 10.5, 20, 21a plus 210d. Now, what can we fill in for the sum of the first 21 terms? Another way to think of it, they've given me this and I haven't used it. So 94.5 goes in for that. And then all you've got to do simultaneous equations with those and you'll get a and d, your first term and your common difference. And then it says find s of 30. To find s of 30, just use your first term and your common difference and hopefully it'll work out from there. I hope that helped. I'm sure you can let us know if you need anything else.